coming, Bruce. It's already here. Where are they?
Projectile motion with trigonometric ratios.
Destroyed your hammer like a piece of glass.
Some old hags. Sine of alpha equals the ratio of the opposite side, uy, over the hypotenuse, u total. Rearranging, the opposite side is equal to sine of alpha times the hypotenuse. Basically, the vertical velocity of Thor's hammer is the sine of the angle of throw times the speed of throw. Substitute this into the final velocity equation. Final velocity will be determined by what angle Thor throws, how fast, and how much acceleration is applied. Gravity accelerates Thor's hammer downward at negative g.
I lost my hammer, like yesterday, so that's still pretty fresh.
Substitute vertical velocity into the displacement equation to find Thor's hammer at any time. The location of Thor's hammer will be determined by what angle Thor throws, how fast and how much acceleration is applied. Gravity accelerates Thor's hammer down at negative g. With the velocity equation you can find Thor's hammer fast.
That feels like an oversimplification.
The difference between the initial and final velocity squared is equal to the acceleration times the distance it travelled going up and coming down. So the difference in velocity squared divided by twice the acceleration gives the distance it acted over. Substitute initial velocity into the equation to find Thor's hammer in no time. Gravity accelerates Thor's hammer downward at negative g. At the maximum height, Thor's hammer is free falling, so its final velocity is 0. Can't always hide. Cos of alpha equals the ratio of the adjacent side ux over the hypotenuse u total. Rearranging, the adjacent side is equal to cos of alpha times the hypotenuse. Substituting, the horizontal velocity of Thor's hammer is the cos over the angle of throw times the speed of throw. Substitute this into the final velocity equation. Final velocity will be determined by how fast Thor throws his hammer, at what angle, and how much acceleration is applied. Without air friction, Thor's hammer does not accelerate. Substitute horizontal velocity into the displacement equation to find Thor's hammer at any time. To find Thor's hammer in a flash, use speed instead of time. Make time the subject of the final velocity equation. The time of flight is equal to the final velocity minus the initial speed and angle of throw divided by acceleration due to gravity. Substitute this into the displacement equation. On the horizontal plane, what goes up comes down with the same velocity. Substitute the initial velocity in the other direction to give you the range of Thor's hammer.
He said he'll fight with us?
Probably more or less.
He said no.
He said no.